Math 3, Unit 6, Section 5. Today we're talking about rational exponents. Okay, so remember that exponents are the same thing as powers. Okay? So there are a lot of laws of exponents. Okay? One thing to know is that you can go back and forth in between root form and exponential form. Okay? And so in exponential form, the one here, the number here on top, represents like the power or exponent. And the bottom number, like the n, that is your index. Okay, so like the index value for the root. So you can go back and forth between root form and exponential form in order to solve a problem more easily. Okay? Now, I want you to turn the page here for a minute. And I want us to talk here about properties of exponents. Okay? So over here we have multiplication properties. So notice here that both of these have a base of a. So when these are like bases, you can add the exponents. Okay, for this example here, both of these have a base of 8. And so they're able to add the exponents 1/3 plus 2/3, which ends up making 3/3, which is 1. Okay? Powers to powers like this is a power to a power, you multiply the exponents together. So looking at this right here, you have 1/2 to the 4th power. They multiplied 1/2 times 4, and 1/2 times 4 gives you 2, because you'd end up with 4 over 2, which reduces to 2, and so that answer is 25. Okay? And then here, whenever you have parentheses, you need to remember that that exponent goes to every single thing inside of the parentheses. When you have a negative exponent, what do? Yeah, you change the side it's on. Okay, and so this right now could really be you can write any number as a fraction by putting it over 1. And so anytime you have a negative exponent, it changes the side that it's on. Okay? Here, if you have the same bases, you subtract the exponents. So here they have the same base of 7, so they subtracted 3 over 2 minus 1/2, and they ended up getting, it would be 2 over 2, which reduces to 1. Okay? And then again, anything with parentheses, that exponent goes to everything inside. And you guys have seen a lot of this before, correct? Yeah. You should have. It's just now we have some fractions. Okay? All right, so we're going to go back and do some problems, starting back here. Okay, so looking at this problem the way it's written right now, I am not sure what the answer is, but I know that I can change this into root form. Okay? Remember that this bottom number represents the index number, and this top number would be like the power that you would raise it to, or the exponent. So to rewrite this one, you write your index, so it's the cubed root of 64, and then I could raise that to the first power. This first power can be to the whole thing, or you could just put the first power to the 64. It can go in either spot. What does 64 break down to? What two numbers do you think of? 8. 8 and 8, right? Most people. But I need how many for a group? 3. But I know each 8 actually breaks down to what?
2, 2, 2.
2, 2, and 2. So that's a group. And another 2, 2, and 2. That's another group. And we're not left with anything left over. And so what's 2 times 2? 4. And then if you were to raise 4 to the first power, it would still be 4. So looking at it in this form, I couldn't solve it But when I changed it to radical form, I could. So we're going to be going back and forth based on the easiest way for us to solve problems. Okay, so going to this next one, I noticed that both of these have the same base. What happens when they have the same base?
You can change them.
No, you can add the exponents together. Okay? And so that means I'm really having -2, and I'm going to add 2/5 plus 3/5. And what is 2/5 plus 3/5? 5/5, which most of you know is 1. And so -2 to the first power is? -2. Okay, sorry, I was a little worried there for a second. Okay, I want you to do number 11 on your own. I'm going to give you about 30 seconds. Or sorry, the one with the 11s in it. Okay? Okay, so check in your groups. I'm going to end up pulling a 6 to help me out here with this one. Okay, so this person's going to help me out. Ethan, you are the chosen one. You're not done? Okay, well then we'll do this together. Okay, do they have like bases, Ethan?
Yes.
Yes, so that means my base is going to stay. Very good. And then because the bases are the same, what can I do with the exponents? No. So you only multiply them together when it's a power to a power. So right now we can do, because if I were to have, Ethan, let me show you. The rest of you need to stop talking. If I had x squared times x to the first, what would that answer be? X to the third. And so what you did is you added those together. The same thing is here. Okay, so since these bases are the same, here the bases were both x's, now my bases are both 11s. We add 1/2 plus 1/2. And what is 1/2 plus 1/2? Since they have common denominators, you add the tops together. So 1 plus 1 is 2. So that's 2 over 2, which reduces to be what? 1. And 11 to the first power is just 11. Okay? All right. Moving on. Okay, what do we notice about this next one?
They have different bases.
So can I add the exponents together? No, you can only add the exponents together if they are the same base. So on this one, we're going to change it to root form and see what happens. So how do I write 3 to the 1/2 power? Very good. So we have this square root of 3 because 2 is my index, and then it would be 3 to the first power, which is just 3, okay, times, and then how do I rewrite 12 to the 1/2 power? Square root of 12. Okay, now, do these have the same index? Yes. And so therefore, when they're the same type of roots and they have the same index, we can do what with them? Multiply them together. And so I'm going to write this as root 3 times 12. And can 12 be broken down?
Yeah.
To what? We could do 6 and 2.
4 and 3.
I'm going to do 3 and 4 because then I have a pair of 3s. And then 4 breaks down to 2 and 2. And I have a pair of 2s and nothing left over. And so what is this answer? 6. Yes. Yes. So yeah, lots of ways to solve it. You could also multiply 3 times 12 together, get 36, and then break it down that way. Whatever way makes the most sense to you, you could do it that way. But here, it looked like it was unsolvable. But when I changed it to root form, I was able to do it. Okay? So, moving to the next problem. The way this is written, I am not sure how to find the answer. Okay, do you guys have questions? Because there's a lot of side conversations going on. Okay, so we are going to change this to our root or radical form. So I'm going to give you about 30 seconds in your groups, change it, and then I'm going to pull a stick for someone to help me. Okay, so I want this person to help me, Brent. And I'm not lying. Okay, all right. Okay, so the 3 is our what? Our index, good. And then you said negative 27, and then what? Good. And so on this one, I would do it to the power of 4, just like this. Does anybody have questions up to this point? Okay, so I'm going to draw another stick to help me work through. My question is, what do I do with the negative inside of a cubed root?
You take it outside.
Very good. We're going to take that outside. So, and actually it's not outside of the parenthesis. It should be actually outside right here. Okay, so we have negative cubed root of 27 and then to the 4th power. Okay, can 27 break down?
Yes.
What does it break down to?
3, 3, 3.
Very good, 3, 3, 3. So I have a group of 3s because I need 3 because of my index. And so this ends up making negative 3 to the 4th power. And what is negative 3 to the 4th power?
27 times 3 is 27 times 3.
Which is 81. Or, like how I do it in my head is I'm like, negative 3 times negative 3 is 9. And then because it's to the 4th, I'd have another 9, which is 81. Okay. Questions? All right. Powers to powers. What do I do with powers to powers?
You multiply.
Very good. If you don't remember what to do, I saw someone in class look back and be like, powers, oh, there it is. Powers to powers, we multiply. Okay, use your resources. Okay, so this is a power to power. So that means we're going to multiply. So I'm going to end up with 5 to the root 3 times root 3. What is root 3 times root 3? Very good. So we have 5 to the 3rd power. And what is 5 to the 3rd power? 125. 5 times 5 times 5. Okay. Any questions? Okay. Here they want us to write each expression in radical form. We need to change this into radical form. I'm going to give you a minute or less to change it, and then I'm going to pull a stick. W to the 5/8. Sorry. Thank you. There we go. Okay, did you guys already get it? Okay, you guys ready? Here we go. Faith, help me out. What's my index? 8. And then W is going to be to the 5th. So this time I just put the 5th power inside because I can't even simplify the 8th root of W, right? So the fifth power can go inside, or you could simplify it and then take it to the fifth power. It works the same way. So on this one, it doesn't matter if you wrote it like this, or if you wrote it as the 8th root of w to the fifth power like that, that's also okay. But these both mean the same thing. Okay? More often, though, you'll see the answer like that. Okay. Negative exponents. What do I do with negative exponents? That's it. There's nothing you can simplify. We don't have 8 of anything.
So we just leave it, or we have to put?
You have to change it. We can't have a negative exponent ever. Okay, and so changing the sides is correct. Well done, ladies. Okay, so we take this and we have to move it to the denominator. So I have t to the 2/3, and if nothing is on top, it is a 1. Now, this represents what? It does, but specifically in the bottom, when you have a fractional exponent, it's actually a root. Okay? Are we allowed to have roots in the denominator?
No.
Okay, I'm going to show you what this looks like. So this is really the cubed root of t squared. Now, this is not okay to have this as an answer. So what will I do?
Multiply by t.
Multiply by what? The cubed root of t. Because when I do that, what happens? We have 3 t's, so I have a group. But whatever we do the bottom, we also have to do to the... And so on the top, 1 times the cubed root of t, you can write it as 1 cubed root t, or just the cubed root of t, over, and this made a group, nothing left over, so t in the denominator. And that's my answer. That is okay. Do you want to ask me any questions about that one? Okay. I do not like this decimal.
Neither do I.
Okay, could I change that to a fraction?
Yes.
How could I change this to a fraction?
26 over.
26 over
100. 1,000. 10.
10.
Oh.
Why is the answer 10? 26 over 10.
6 is in the 10th place.
Whatever place the decimal goes out to, that is what you can write that as a fraction over. And so this is the same thing as y to the 26 over 10. And if you were to put that into your calculator, 26 divided by 10 is 2.6. Okay? If this number had gone out to the hundreds place, then I would write it over 100. Okay, can this be reduced?
Yes.
Okay, and so it's really going to be y to the what? 13 over 5. But they want it, the instructions were to write it in radical form. So, how will I write this? Good. So the index is 5, 5th root of?
Y to the 13.
Okay, is this okay? Because I can still do what? I can reduce, I can simplify, correct?
Yeah.
Okay, how will I write this out to simplify it?
Y.
How many do I need for a group?
5.
So y to the 5th, that's 5. Another 5 makes,
10.
and another 3 makes the,
13.
so I have 2 groups of 5s and 3 left over.
Y squared.
Good, so the final answer is y squared and the 5th root of
Y cubed.
y cubed. Okay, any questions there? Next, they want us to write these in exponential form. Change this to exponential form. Ready, set, go. Okay, so get ready to help me out if you want to check your answer in your group really quick. I'm going to pull a stick. And the person that's helping me is Lily. What is it in exponential form?
Stop it. That's 3 over 4.
Very good. 3 over 4. The index always is in the denominator. The power's on the top. That is it. There's nothing left to do. Okay. Next one. I want somebody to help me write this in exponential form. The square root of 10. How do I write that? Michael. Uh-huh.
1.
Your name's not Michael, so you're good. Okay, so you start with this number, which is what? 10. What is the index of this?
1.
What will we call this?
Square root.
A square root, which means that it's
Oh, 2.
2. The index is 2, so the index goes in the denominator.
1.
And then 1. The power is 1 if it doesn't say. So that's 10 to the 1/2. Okay, are we okay with this? Okay, now we're going to change this one to exponential form. Okay, I'm going to pull a stick and you're going to help me. Are you ready? Okay. The lucky one is Jason. Okay, so what are we going to start with? Do you know? Okay, that's going to be like our base, okay? So, we have 2ab, and I'm going to keep it in parentheses, okay? And we know it's going to go to a fractional exponent, okay? What number is going to go on the bottom?
Bottom is a 4.
Very good. What number is going to go on the top?
12.
That's it. And can that reduce?
Yes.
To what?
3.
Very good. So 2ab to the third power, and that's it. Okay, or if you wanted to distribute that third power through there, you could, and that would be 8a to the third, b to the third. So either of those answers would be appropriate. Any questions? Okay, moving on. Okay, so all of these, they just want you to write them in simplest form. Do these have the same index? No. So can I multiply them together the way they are right now?
No.
No. But can I change them to exponential form? The correct answer is yes. Nick, we can change them into exponential form. Okay, how do I write 3 in exponential form? I'm going to pull a stick. How do I write 3 in exponential form? Help me out, Maddie. So you always start with the number that's underneath there. Okay, so what number is that? Very good. Okay, the index tells us the denominator. What's the index? Yeah. And is there any exponent here with the 3? No, so that means on top is a 1. Okay. I'm going to pull another stick. Help me write this one now in exponential form. Devin.
It's 3.
Uh-huh.
1/4.
Very good. Now, do these have the same base?
Oh, yeah.
Yes. So, since they have the same base, that means what?
You can,
You can add the exponents. Okay? So, I know that my answer, the base is going to be 3. I need to add the exponents to figure out, I should box this, what value is going to go there. Okay? 1/2 plus 1/4. In order to add those, they need what? What will be my denominator? 4. Okay? And so if I want each of these to be a denominator of 4, this one already is, so we keep the 1. 2 times 2 is 4, so 1 times 2 makes 2, and that adds to make what? 3/4. So the answer is 3 to the 3/4 power. I'm going to rewrite that because you can barely see it. Okay, next one. Do these have the same bases? So what does that tell us? We can add them together. So in my answer, my base is going to be what? X. But in order to find out the exponent, I have to add. So 4/3 plus 5/6. What would be my common denominator? 6. Okay, so I'm going to rewrite both of these with denominators of 6. This already has a denominator of 6, so we keep our numerator the same. This one, I want it to be a denominator of 6. What do I do to 3 to make it 6? And 4 times 2 is 8, and you add that together, and what do you get? Okay, and so that means my answer is x to the 13 over 6. Are we okay? All right, what do we do with the negative exponent?
Put it as a denominator.
You change the side it's on. So this whole thing is going to a negative exponent. So this whole thing goes to the
Bottom.
denominator. Very good. And so we have 1 over 5x to the 3/4. Is that okay?
No.
Why not? Because fractional exponents represent roots. And we can't have a root in the denominator. Right, Michelle? And so this means I have a root in the denominator. Okay? So if you want to, you might want to rewrite it with a root. How do I change this to be in radical form?
4th root of 5x.
What? So the index is 4, the 4th root of x to the 3rd. Okay? Is it okay to have a 5 in the denominator? Yeah. Just not a root. So how could I eliminate that root? What do I still need?
An x.
We need one more x. So we're multiplying by the 4th root of x, because that will now give me a total of 4 x's, right? Which is a group. But whatever I do at the bottom, I have to also do to the top. So what is this answer going to finally be?
The 4th root of x over 5.
The 4th root of x over 5x. Because I still have the 5, and then the group of x's makes an x. Okay. Do we have questions right now?
Yeah, why did you take the 5 out? Why is that out from the radical?
Good question. So do you see here, this 3/4 is only touching the x. I would have put everything under if it was like in parentheses with the 3/4. Okay? All right, anything else? Okay, what do you notice about this next problem right here? Look at the indexes. They're different. Because the indexes are different, I can't reduce, I can't do anything. Therefore, we're going to change this to what form? Exponential form. Okay? So starting with the top, I'm going to pull a stick. Help me change this to exponential form. Help me out, Morgan. What will that be in exponential form? X to the 3 over, and what's the index? 2. So it's x to the 3 over 2. Good job. Okay, over. Okay, somebody help me out with this one. And Caitlin.
X to the 3 over 2?
Nope.
Oh, no, 2 over 3.
2 over 3, good. Because remember the bottom number is your index. Okay, good. Now, do these have the same bases? Yes. And so since they have the same bases, what can I do?
x.
So we're not going to add the exponents because it's not multiplying. What do you do with the exponents when it's dividing? Subtract, right, Ethan? Yeah. So I'm going to subtract these values. 3 over 2 minus 2/3. But in order to subtract fractions, you need what?
Common denominator.
What will be my common denominator?
6.
6. Okay, so here, 3 times 2 is 6. So 3 times 3 is 9. Here, 3 times 2 is 6, so 2 times 2 is 4. And then 9 minus 4 is 5/6. So how I write this answer? X to the 5/6. Okay. The way this problem is written is the same thing as y to the 3/5 divided by y to the 4/10. Can we simplify this one?
Yes.
How do we do it?
Same base.
Same base, very good.
Subtract.
So we're going to subtract the
Subtract.
exponents. Okay, good. All right, so 3/5 minus 4/10. What would be my common denominator? 10. So I rewrite this with common denominators. This already has a 10, so I keep the 4. And then 5, we multiply it by 2. So 3 we multiply by 2 and get 6. And 6 minus 4 is 2/10, which can reduce to, and so my answer is y to the 1/5. Well done. Okay, do you want to ask me any questions? Okay, next one. What does this 1/2 out here mean? Yeah, there's a lot of ways of doing this, but since you guys thought of square root, let's just do it that way. That means that this whole thing is under a square root. The square root of 50x to the 16th over 18y to the 8th. Okay, what would you do first on this problem? Yes, good. Bless you. I would always, Michael, start by reducing if you can. Okay? And so what can go into, how can 50 and 18 both reduce? 50 divided by 2 is? 18 divided by 2 is? 9. So now I have 25x to the 16th over 9y to the 8th. Okay. Also remember that this is the same thing as the square root of 25x to the 16th over the square root of 9y to the 8th. So what will we do? What happens to the top? We're going to plot any groups. So yeah, so 25 is what?
5.
So we got a pair of 5s. And then how would I write out x to the 16th?
X to the 8.
Yeah, I'm going to write it out, but some of you can do it in your head, and that's fine. So I'd count out by 2s. So 2, 4, 6, 8, 10, 12, 14, 16. How many groups do I have? So we end up with 5x to the 8th on the top, nothing left over. And then, oh, sorry. What happens in the denominator? 3 and 3. And y to the 4th, or 2, 4, 6, 8, 1, 2, 3, 4 groups, so 3y to the 4th. Can I simplify anything? No. Okay. Are we good? Yes, Dylan.
Wait, so why do you make it a fraction?
So this 1/2 means it's an index, a square root of 2 to the first power, so I don't have to write it.
No, I mean like make it two separate, but
Oh, so anytime the whole thing's over a square root, each piece is, if it's saying the whole thing is a square root, that really means the top is a square root and the bottom is a square root. And then you can simplify them separately. Okay, last one. What do you think you should do first?
You should switch the
Good. Nick is correct here. Negative exponent needs to go to the bottom. This negative exponent needs to go to the top. So we're going to rewrite this. So I still have x to the 1/5, but this y to the negative 1/2 goes up. So that's now y to the 1/2 on the top. And then on the bottom, I still have x to the 1/2. And then the y to the 1/5 goes to the denominator. Okay. So you can think of these as like separate problems, and you can just deal with like the x's first and then deal with the y's. Since these have like bases right here, what will I do? Subtract them because it's dividing. So 1/5 minus 1/2. What would be my common denominator? 10. And so 2 times 5 is 10, so 2 times 1 is 2. 2 times 5 is 10, so 1 times 5 is
5.
And you get a -3/10. So what do you think? So if you want to, we could just write that as x to the -3/10 for right now. Okay? Now let's deal with the y. Okay, so on the y's, we're going to take what? 1/2 minus 1/5, which is not exactly the same thing. But again, we're going to get a denominator of 10. Here I multiply by 5 and I get 5 over 10. Here on this one, multiply by 2. Oh, I'm sorry. Thank you. And we get 2 over 10. And so 5 minus 2 equals, so I have y to the 3/10. So if you are writing this together now, does anybody know how you would end up writing it?
Y to the 3/10 on the top and x to the negative, or x to the 3/10 on the bottom.
Yep. Because the x was negative, that would go to the denominator to make it positive, and the y being positive stays on the top. Now, is this okay? Why not? Because this really represents a square root in the denominator. Okay? So, you can leave them this way, or we could change them to roots if that makes more sense. Okay, some of you might know how to deal with it with exponents, but instead of trying to teach you one more thing, I'm going to change both of these to roots. So this is going to be the 10th root of y to the 3rd over the 10th root of x to the 3rd. Does everybody agree with that? Okay, so what do we have to do? What do we need?
Multiply x to the 7th.
Very good. The 10th root of x to the 7th. Okay, that's one group, right? So what's in the denominator? Just x? Do these have the same indexes? Yes. So 10th root, and then you would write it normally in alphabetical order, x to the 7th, y to the 3rd, because there are no groups.
Yes.
And that's your final answer.
Miss Otto,
Yes.
can we have a break?
Yes.